Hello and welcome back to the Math 055 Notes. This is a section over 8.1 and we're going to be talking about quadratic equations. And what we're going to be doing today is we're going to be solving quadratic equations. And the first thing I want to do is write a little note for what a solution is. Okay, and this is going to help us through this section and through the rest of this class. And I want you to remember, and we learned this back in section 5, that the solutions to quadratic equations is where the graph crosses the x-axis. Okay, that's really important that we know that. Okay, and we're going to talk more about what that looks like here in a bit. But the first thing I want to do is this. I want us to let's take a look at these two options for solving quadratic equations. Okay, the first thing we want to look at is, can we factor the quadratic? Okay, can we factor the quadratic and set each of those binomials equal to 0 and solve? Okay, that's what we did in section 5.8. Okay, but we need to use, what we're going to start using in this section is this thing called a principal square root. Okay, and let me kind of just go over what that looks like. Okay, so let's think of an example. All right, so let's look at this guy first. Let's look at the equation x squared is equal to 4. Okay, so let's just think about it. I take some number and I square it and I get 4. All right, what could that number be? What number could I square that gives me 4? Now, what we have to realize here is that, and you can think intuitively about this. All right, I know that x is going to be either 2 or x could equal -2. Okay, and the reason I know that is just because I'm just thinking about it. Okay, I know that 2 squared, let me write this over here, that 2 squared is going to give me 4. Okay, and I know that if I take -2 and I square it, okay, that's -2 times -2, which is also going to give me +4. Okay, so I get 2 solutions out of this. All right, and then that's what I know. Okay, and then let's do this. Let's do let's just solve this. Let's just solve it. All right. So if I wanted to solve this equation for x, what I have to think about, with x squared equals 4 is, I want to undo squaring something. Okay. And we've kind of done this already before, where if I square something, the opposite of that is taking the square root. So if I take the square root of both sides, okay, then I get this. Then I get x is equal to. Now, when I apply the square root to this, I get plus or minus the square root of 4, okay? And the square root of 4 is 2, so x is going to equal positive or -2, okay? And so, understanding why you have to have the plus or minus is because of, just thinking about, what solutions could you have, okay? And whenever I take the square root of both sides and I undo squaring something, I put in the plus and minus, okay, and that's what we get. All right, let's take a look at what this would look like graphically. Now, when I think about this, if I wanted to graph this equation, x squared is equal to 4, what I want to do is I want to set this equal to 0. So I'm going to subtract 4 from both sides, okay, and so I get x squared minus 4 is equal to 0. Okay, this is what I'm going to put into my calculator and graph. And I'm just going to plug this into Desmos real quick, and we're going to see where it crosses the x-axis. Okay, so once I graph this, okay, you remember, look at what we're looking for. We're looking to see where this graph crosses the x-axis. And what I notice is that this graph crosses the x-axis at -2, and it also crosses the x-axis at +2, okay? And so those are my solutions, okay? So you can check yourself graphically, or, what you can do is graph one of these one of these equations, and then see, what your answers are supposed to be, and go from there. Now, this may not work for every single one, but it'll work for a lot of them, okay? All right, so now, what I'm going to do is use that same idea to apply it to other problems here and here, okay? Now, in other typical quadratics, they came in the form of ax squared plus bx plus c, and with something like that, we either factor, but we can't always use the principal square root. But I want you to notice something interesting about these two examples. This one only contains an x squared, okay? This one contains a quantity squared, okay? When I see these, it tips me off that I need to use this concept to solve them, okay? So let's go ahead and take a look at this one. And the first thing that I'm going to do, what you want to do is you want to isolate your x squared, okay? Get whatever is squared onto one side of the equal sign, and then apply the principal square root property. The first thing I'm going to do here is divide both sides of this by 12. Okay, so the first thing I'm going to get is x squared is equal to 49 twelfths, okay? And I'm going to take the square root of both sides at this point. I've isolated my x squared. I have something squared on the left side and a number on the right, okay? So I'm going to do that. So I'm going to take the square root of both sides, okay? And I get that x is equal to plus or minus the square root of 49 over 12. Now, this is a number, but we want to simplify this, okay? That's not, this is technically your answer, but this isn't in proper form. So we want to do the simplification that we've been doing in the last couple sections in order to break this down into a usable form, okay? So let's do this, all right? This may take a few steps, but that's all right. All right, so I've got x is equal to plus or minus the square root. Now in the numerator, I've got the square root of 49 divided by the square root of 12 in my denominator. Okay, now the cool thing is that over here I can take the square root of 49, okay, but I can't take the square root of 12. So let's go ahead and just take the square root of 49. Let's do this step by step. So x is equal to plus or minus, the square root of 49 is going to give me 7 over the square root of 12. Now, what I can do, the square root of 12 can be simplified, okay? And I want to simplify that before I just jump right into, rationalizing my denominator. So let's simplify this before we rationalize our denominator. So I've got x is equal to plus or minus the square root of 7 divided by, okay, the square root of 12, I'm going to rewrite that as the square root of 4 times the square root of 3, okay? And I'm going to bring this next step up here, okay? And I'm going to write x is equal to plus or minus 7 divided by 2 times the square root of 3, okay? And so all I've done is just, I've taken the square root of 49, I've simplified the square root of 12 to get this. Now, once that's simplified, I want to rationalize my denominator. So I'm going to multiply both the top and the bottom by the square root of 3. Okay, I'm going to do that up here and down there. All right, so then I get x is equal to plus or minus 7 times the square root of 3 divided by 2 times the square root of 3 times the square root of 3. Okay, or square root of 3 squared, doesn't matter. And when I get that, all right, square root of 3 times the square root of 3, okay, that's just going to give me 9. So I got x is equal to 7 square root of 3 over 2 times, this part here becomes a square root of 9, which is just 3. All right, squaring a square root of 3 is just going to give you 3. All right, so we're not done. One more step, okay? And so I get that x is equal to plus or minus 7 square root of 3 over 6, okay? This is my proper answer that I'm looking for, okay? Now on this one, because you have a real numbered, solution, it's going to be a decimal, but because this is a real numbered solution, let's just go ahead and check the graph on this to see what we get. Now, before I graph it, let's do this. Let's do Okay, let me take my original equation here, and let's do 12x squared equals 49. I'm going to subtract 49 from both sides. Okay, and I'm going to get 12x squared minus 49 is equal to 0. This is what we're going to plug into our grapher. Okay, so once I've done that, let's go ahead and plug this into, let me pop up this picture here real quick. And I'm going to do the whole thing so you guys can see what I'm doing here. So, you know, this is what I plugged into my grapher, 12x squared minus 49. You don't have to put the equals 0 part. But what I did was I plugged that in and I got these two numbers here. Now, these two numbers, negative 2.021 and 2.021, don't necessarily look like what I had, okay? But when I plugged it in on my grapher, okay, I also put in 7 times the square root of 3 over 6, the answer that we got, and that's the same thing, that's the number here, 2.020729259, whatever. Okay, round that up, that's going to be 2.021, so it is the same thing. So when you get answers like this, they're not going to come out nice and even. They're going to be in decimal form, so it's important that you guys graph that, you know, and see what you get. All right, you get some crazy decimal. Then let's go ahead and plug in what we get for, you know, as our answer algebraically, and then go from there. Okay, so that's the idea. All right, so now let's go back and let's take a look at part B. All right, now part B is very similar. You know, the only difference with part B is that you have a quantity here squared is equal to negative 9. Okay, so 5x plus 2, that quantity squared equals negative 9. Now, your first inclination would maybe be to, you know, multiply all this out and solve from there, which you can technically do, but when it's already in this form, when you already have some quantity squared is equal to negative 9, just go ahead and take the square root. Okay, so I'm going to take the square root of both sides, because what that's going to do is that's going to undo the square, and the only thing you're going to have left over here is just 5x plus 2. Okay, now remember that when you take the square root of negative 9, that you're splitting this up into the square root of 9 times the square root of negative 1. Okay, and remember that if you take the square root of a negative number, which we can do now, okay, that's going to give me 3 and then I. Okay, and that's that. All right, now what I've got 5x plus 2 is equal to 3i. Okay, and this is plus or minus, sorry. Okay, just got to make sure you put the plus or minus there. Don't want to miss that. Okay, so now what I want to do is I want to solve this for x. You know, that's still my goal here, is to solve these for x. So what I'm going to do is I'm going to subtract 2 from both sides, okay? And I'm going to get that 5x is equal to negative 2 plus or minus 3i, okay? Now, if I divide both sides by 5, okay, I'm just going to divide it by 5, I get x is equal to negative 2 plus or minus 3i over 5. Now, I can't simplify this any further. For number one, I can't combine the negative 2 and the 3i because this is an imaginary number and this is a real number, okay? So I can't combine those, so I just have to leave it like that. And then if I divide everything by 5, you know, 2 doesn't go into 5. I can't simplify this, nor can 3 be simplified into 5. So I just leave my answer as is, okay? And that's that. This is a little tricky because, you know, this is not something that you probably see very often, a number that looks like that. Okay, now your solution, you get two numbers out of here. You get x is equal to negative 2 plus 3i over 5, or you get x equals negative 2 minus 3i over 5. Okay, and that's what that plus or minus means. Okay. And so let's go ahead, let's plug this into the graphing calculator and see what we get. Now, if I plug this into the graphing calculator, if I take in my original equation 5x plus 2 and square it is equal to negative 9, I would add 9 to both sides. Okay, and let's just take a look at that graph and see what we get. So 5x plus 2 squared plus 9 equals 0. Okay, this is what's going to go into my graph. All right, and so if I put that into my graph, Let me pull that image up. Okay, and here's what we get. Okay, now what I want you to notice here is that this graph does not cross the x-axis. Okay, it's not going to hit it. Therefore, we're not going to have real solutions. And that's the big thing about imaginary solutions. That's essentially why we have imaginary solutions. So, that is where, graphing can be very powerful to check your answers. But if you don't have, real numbered solutions like we do here, then graphing these can be kind of tricky, okay? All right, now let's go ahead and let's talk about something down here called solving a quadratic equation by completing the square, okay? And the goal, and let's write this down, okay, because this is kind of a tricky section. The goal of this section, all right, of completing the square is to manipulate a quadratic in the form ax squared plus bx plus c equals 0 into x minus h squared is equal to some number k. All right. So our goal is to go from this form here down to this form here. Okay. This is what I call completing the square. All right. And so the easiest way to do it is to kind of just jump in and do some examples. Okay, so I'm going to do that on the next page and show you how I do that. Okay. All right, so let's take a look at this next page. Okay, so on this problem, we want to solve the following by completing the square. We want to write our answer in simplest radical form and use I if necessary. Now, what I want you to notice here about this quadratic is that we can't just solve it by factoring. Okay, so that's the first thing you look for first. Can you factor this? And, two numbers that multiply to 2 but add to 6, that's not going to work. Those numbers are just 2 and 1, and then you should get 3 here. Okay, so because this isn't 3, this can't be factored, okay, essentially. All right, so what I want you guys to do here is we want to manipulate this and turn this into a perfect square, okay? And here's what I want to do, okay? The first step is this, all right? I want to move over this 2 to the other side, okay? And so my first step is going to be subtracting 2 from both sides, all right? And my next step is going to look like this. X squared plus 6x plus blank is equal to negative 2. Now, what I want to do is I want to put a number in here. Now, if I do it to the left side, I have to do it to the right side as well. So I'm going to do a plus blank here, okay? So right now where I'm at is I have just done this. I have just moved over the 2, and I've left a space for this number here and here, okay? Now, what's going to go in the blank, okay, is I'm going to take my middle term. So for the blank, so I'm going to write this up here. So for the blank, okay, take your middle term, divide it by 2, and square it, okay? And the reason I'm doing that is to create a perfect square trinomial. So what I'm going to do over here, and I always take this number, so it's always my middle term here, negative 6. I'm going to take 6, I'm going to divide that number by 2, and then I'm going to square it. Okay, and that's a number that's going to go into my blanks, okay, here and on the other side of the equation. So I've got 6 divided by 2, which is going to give me 3. And then we're going to square it, and that's going to give me a value of 9. Okay, so 9 is the number that I'm going to put into here and here. Okay, now what I want you to notice about this left side is that I can now factor this, all right? And I'm going to ask if I factor this and I say, okay, two numbers that multiply to 9 but add to 6 is 3 and 3. So this left side of the equal sign can be factored down to x plus 3 times x plus 3. And that's going to equal negative 2 plus 9, which is going to give me 7. Okay? So when I take some number and multiply it by it, or some binomial and multiply it by itself, what I end up getting is I get x plus 3 quantity squared. And that's going to equal 7. Okay? And this, what I have done is I have taken this equation here and I have manipulated it and put it into a form of some quantity squared is equal to a number. That's the whole idea. Because now what I can do is I can take the square root of both sides, here and here. And what I've done now is I then get x plus 3 is equal to plus or minus the square root of 7. Now I can't take the square root of 7, so I'm just going to leave it like that. All right, now what I'd want to do to solve is I would want to do this. I'd want to subtract 3 from both sides, okay? And I get that x is equal to negative 3 plus or minus the square root of 7. Okay? Now, I'm going to go ahead, and so here's the other thing that we get. Okay, I'm going to put all this in the calculator and show you how this works out, because these are real numbers. They're not imaginary. So this is really, I get x is equal to negative 3 plus the square root of 7, or I get x is equal to negative 3 minus the square root of 7. Okay, these are my two answers, okay, that we get. Now, these are going to be decimals, okay, when we graph this. So let's go back and let's graph this. Okay, and so when I graph this, okay, I want you guys to notice something. You know, when I plug this graph in, okay, my original graph, these are the answers that I get. I get negative 5.646 and I get negative 0.354. Okay, these are my x-intercepts. Now, in order to figure out my decimals on the other side, I had to plug in negative 3 plus the square root of 7 and negative 3 minus the square root of 7. And those gave me these two numbers here, all right? And those are the solutions, okay? These are the exact solutions, and you can approximate them. I don't want decimals. I want, you know, the exact form of these, okay? So this is how you solve any quadratic by completing the square. It's actually kind of a powerful tool, okay, that we use. All right, let's take a look at part B. Part B, we're going to do it the exact same way, okay? Now, the only difference is that we're dealing with a different variable here with y, okay? That doesn't matter. We're still going to use the same process that we had, okay? The first step we're going to do is we're going to subtract 30 from both sides, okay? So I'm going to subtract 30, move that over, because this is not factorable, okay? And when it tells you to do it by completing the square, typically that tips you off that you can't factor something, okay? So this is not factorable, okay? Two numbers that multiply to 30 but add to negative 9, that's not going to work. So let's go ahead and solve this, all right? So I'm going to subtract 30 from both sides, and I'm going to get y squared minus 9y plus blank is equal to negative 30 plus blank, okay? Now, what goes in the blank? Remember, we take our middle term, which is negative 9, okay? I'm going to divide that by 2, and then I'm going to square it, okay? Now, this is going to get a little weird here because we're going to get a fraction. So over here, okay, what I'm going to get, negative 9 divided by 2, okay, I can't do that readily, okay? Negative 2 doesn't go into negative 9. So I'm just going to square this as is. So if I square it, I'm going to get negative 9 squared is going to give me positive 81. And then 2 squared in my denominator is going to give me 4, okay? So this is the number that's going to go into my quadratic here, all right? So 81 fourths. And then on this side, we're going to get 81 fourths. Okay. Now, believe it or not, what you have on this left side is a perfect square trinomial. This is factorable. Okay, now the trick is to understand how we get this number. Okay, remember we're taking our value here, dividing it by 2, and we're squaring it. Okay, so that act of taking that number, dividing it by 2, and squaring it gives us a perfect square trinomial. Okay, and what this will do, you have to think about it. Two numbers that multiply, or I'm sorry, that add to -9, and two numbers that multiply to 81/4. That's kind of tricky, but you already have that number. So whenever you're dealing with problems where you've got fractions and you can't go anywhere from there, this number is very, very important, -9/2. The reason why that number is important is because this tells me what this factors to. This automatically will factor to y minus 9/2 times y minus 9/2. Okay, now think about something. Up here, look what we had. We had a +3 and a +3. Look what we got as our result there. Okay, that's the hard. That if you can get over that aspect of it and know how to go, you know, I think getting to this step is pretty easy, but then going from this step to this step is kind of hard. But if you remember that the number that you divide by 2, whenever you divide that by 2, is the number that's going to go here. Okay, and that's going to be in your next step. And that's the whole thing about completing the square, is that you are creating, taking this value, this polynomial here, and turning it into a perfect square trinomial. Okay, and so two numbers that would add to -9 would be -9/2. Okay, two numbers that multiply to 81/4 would be multiplying 9/2 times 9/2 gives you 81/4. Okay. All right, now the other hard part is now that I have to add these two numbers over here. Okay, so we got fractions, so I'm going to do -30/1 plus 81/4. Now what I'm going to do is I'm going to put, I'm going to get a common denominator, so I'm going to multiply this by 4/4. Okay, so on the right side here, I'm going to get -120/4 plus 81/4. Okay, and then, and let's do this. On this left side, because I have a binomial times itself, I'm just going to write it as y minus 9/2, that quantity squared. Okay, now if I take -120 plus 81, that's going to give me a value of -39/4. And that's going to equal y minus 9/2 squared. Okay, now from this point what I want to do is I want to just solve this. So what I've done is I've gone from a quadratic up here, okay, to some quantity squared, and that's the goal, is because at this point what I want to do is I want to apply the square root to both sides to solve. Okay, now this is kind of nice. Okay, it may not look nice to you, but it looks nice to me. What I'm left with on the left side is I'm left with y minus 9/2, and that's going to equal plus or minus the square root of 39/4. Now, when I take the square root of, and this is -39. Okay. Now, when I take the square root on the right side, I can't take the square root of my numerator, but I can take the square root of my denominator. So I get the square root of -39/2, and that's equal to y minus 9/2. Okay. Now, what I can do, because I'm dealing with a negative square root, I want to turn this into a, and let me move this up over here. We're running out of room. Let me write this down. Y minus 9/2 is equal to plus or minus. And let's do, so if I do the square root of -39, that's going to give me I times the square root of 39. okay? And that's just dealing with my imaginary number, taking the square root of a negative number over 2, okay? Now what I want to do, in order to solve for y, I'm going to add 9 halves to both sides, add 9 halves to both sides. Okay, so I end up getting that y is equal to 9 halves plus or minus I times the square root of 39 over 2. Okay, and because both of these have a common denominator, that's nice. That's why I said this is a nice problem. I can put that all over 2. So I get the answer of 9 plus or minus I times the square root of 39 all over 2. And that is my answer, okay? And that is, this may be very, very, very confusing to you, but guys, what I'm doing is I'm applying all of the things that we've learned, you know, in previous sections, and I'm applying it here, okay? So this is kind of a tricky little, you know, spot to be in, but it's going to be okay, okay? Believe in yourselves. Okay, now in part C, this is the last one for this section. Okay, so part C, I've got 2x squared plus 4x minus 3 equals 0. Now, the first thing I want to do, whenever you're completing the squares, you always want to have a leading coefficient. The number that's always up front wants to be 1. So because this number isn't 1, I need to turn it into a 1. Now, I do that by division, okay? And I'm going to divide everything here by that number, 2, okay? So 2 divided by 2, that's just 1, so I just get x squared here, plus 4x over 2 is just going to give me 2x, minus 3 halves, and then that's going to be equal to 0. 0 divided by 2 is just 0, okay? So now at this point, what I want to do is now I want to complete the square. So here I'm going to add 3 halves to both sides, okay? And I'm going to be left with x squared plus 2x plus blank is equal to positive 3 halves plus blank. Okay, now in the blanks, okay, what I want to do, remember, I'm going to take my middle term here, which is 2. I'm going to divide it by 1, and then I'm going to square it. So 2 divided by 1 is going to give me 2. Or no, crap, I don't want to do that. I want to take 2 divided by, middle term divided by 2, and then square it. All right, so then 2 divided by 2 gives me 1. So 1 squared is just going to give me 1. So I'm going to put a 1 here and a 1 here. Okay, so what I've got is I've got, over here on the left side, I've got x squared plus 2x plus 1 is equal to 3 halves plus 1. I'm going to put a 1 down here, and I'm going to get a common denominator of 2. So this is going to give me 3 halves plus 2 halves. Okay, so on the left side, I've got x squared plus 2x plus 1 is equal to 5 halves. Okay, now at this point, what I want to do is over here on the left side, I've got a perfect square trinomial. Okay, 2 numbers that multiply to 1 but add to 2 is 1. And remember, the number that you get here is a 1. All right, so I'm going to get that this is x plus 1 times x plus 1 is equal to 5 halves. Okay, so x plus 1 times x plus 1 gives me x plus 1 squared. And that's going to equal 5 halves. Okay, so now at this point what I want to do is I want to take the square root of both sides. Okay, and let's move this up over here. Okay, so on the left side, after I take the square root of x plus 1 squared, I get just x plus 1. And that's going to equal plus or minus the square root of 5 over 2. Okay, now what I want to do, I've got x plus 1 is equal to plus or minus the square root of 5 over the square root of 2. Okay, and so once I have this, okay, I want to rationalize my denominator. So I'm going to multiply the top and bottom by the square root of 2. All right. So what I get is this. I get x plus 1 is equal to plus or minus. The square root of 5 times the square root of 2 is going to give me the square root of 10. And then the square root of 2 times the square root of 2 is just going to give me 2. Okay, so I've got that. And then what I want to do is I'm going to subtract 1 from both sides. All right, so I get that x is equal to -1 plus or minus the square root of 10 over 2. Okay, now technically this answer would be sufficient, but what we would want to do here, with that -1 plus or minus the square root of 10 over 2, I'm going to put this over 1. I'm going to get a common denominator here and multiply it by 2 over 2. And what that would give me is -2 plus or minus the square root of 10 all over 2. Okay, and that would be probably the preferred answer. Either one of these answers would be fine, but the issue is that, if you look up your answers in the back of the book for like odd-numbered problems, then, you're going to see this as your answer, and you wouldn't see this. So that's where it's kind of tricky, okay? Let's go ahead and graph this one and verify that we have the right answer here. All right, so let's go ahead and do that real quick. All right, so we've graphed it. Here's my graph. Okay, I plugged in my original equation, and I'm looking to see where it crosses the x-axis. Now I see that it crossed at -2.581 and 0.581 here. All right, so that's all nice and good, but those weren't the answers that we necessarily got. So I had to take our answers that we got and plug each of those in to find the actual value of those numbers, and it turns out that those are the same values that we got. So you do need to do that for those. Okay, now, I understand that you are probably more than frustrated at this point. This is a very difficult section. This is a very difficult concept to kind of wrap your head around. It is mainly a procedure, okay? So as long as you understand how the procedure works, the problems should be okay? But, it's one of those things where, go back through this video, go back through these problems. It's not a bad idea to try them, again on your own, on like a separate sheet of paper, to see if you're getting the same answers that I'm getting, okay? So a good tactic at this point would be to, I'm going to write A, B, and C down, and I'm going to try them again on my own by doing these, okay? By doing these same problems and trying them on my own and checking your answer to see if you get them right. And if you get them wrong, okay, if you're stuck on a certain part, either go back through the video or go back through the notes to see what to do next. Okay, it's all about how do you go from, one step to the next, from this step to this step to this step, and how am I doing that? And that's what I want to see on your videos. So if you have any questions, feel free to log on to office hours. I think that'll be very beneficial to you, but also, contact me, email me, if you have any other questions. So good luck on your homework, and we'll see you soon. Thanks a lot. Bye.